Hello again, everyone. So I hope you're all guys having a good day. So we have our next problem, no, sorry, next lesson, which is a simple RL circuit problem in differential equation. So of course, expect that we'll be using a differential equation here. So now we have a simple circuit, which is simple circuit RL. What it means is R and L, or the resistor and the inductor, are in series. So now we have a V, or a DC source, that's a voltage, and then we have a R and L. So they are basically in series with one another. So we have also a switch. So this is the switching current. So what we are aiming here, or the objective is during the switch will turn on, that is just a split second. Okay? When you switch, when you turn on the switch, the circuit now will be complete. Okay? Therefore, a voltage will flow onto the circuit, or the current will also flow on the circuit. Now, during the switching, there will be a current flowing on the circuit. That is the current that we will solve. Not the actual current after 2 seconds, after 3 seconds. This will be just during the switching. So it will just be a millisecond. Okay, so we have here R will be the resistance, L is the inductance, and I is the current, V is the DC source, VR and VL are the resistor and inductor voltage respectively. So now, um, let's apply KVL. Okay, applying KVL, let's say that this will be our loop. Okay, this will be the loop, and we have in an I. So if that will be the loop, we will have here, apply KVL. Okay. So applying KVL, you'll have here the V must be equal to the voltage of the resistor plus the voltage of the inductor, right? But we all know that V, using the Ohm's law, VR, that is just I times R, right? The current times the resistor. Plus, for the VL, that will be um, L times DI over dt. Okay. So for the voltage of the inductor, that is L times di over dt, or the change in current. So remember that the inductor is the one that controls the change in current. Next, um, I will divide everything by L, because I want the L di over dt will just be di over dt. So dividing everything by L, you're left with V over L. Sorry, I just make the di over dt first. So L di over dt over L. So L will be eliminated. You'll have your di over dt plus, since I is our variable now, I will isolate I here. So IR over L, you'll have here R over L times I must be equal to V over L. So as you can see, this part is a Folde again, a first order linear differential equation that is linear in I. Therefore, we have to find now the IF, or the integrating factor. To find the integrating factor, whatever is with the I, that must be E raised to integral of R over L times dt. Okay. So this will be equal to the next, so IF now will be E raised to R over L times t. Okay. Now, getting the solution, since this is linear in I, it will be I times the IF, which is E raised to RL, R over LT, equal to the integral of whatever is the left side. On the right side is V over L. V over L, V over L times the IF again, the integrating factor, E raised to R over L, T and dt plus C. Okay. Now, to perform the integral, we'll have here the left side is still the same, RL over T equal to the integral of this one is you have to multiply this by the reciprocal of R over L. You'll have L over R times V over L, right? Times E raised to R over L T plus C. So let's simplify. So L will be cancelled. And then at the same time, I will be multiplying everything by E E raised to negative R over L T. So that this one and this one will be cancelled. But this one will have a E raised to negative RT over L. Okay. Okay, so applying that, you'll have just I on the left side equal to V over R. Okay. And then plus C E raised to negative R over L. Okay. But now we have to find C, right? And of course, we all know that at t equal to 0, of course, there is no current at t equal to 0. Therefore, I must be also equal to 0. So let's apply this one. You will have I equal to 0. So 0 V over R plus um, C e raised to negative R over L times 0. So simplifying this one, of course, you'll know that this just equal to 1. And then that will become C plus V over R. So we have to transpose V over R. Therefore, your C will just be negative V over R. That's it. So we already have the value for C. So let's substitute the value for C, value of C to this equation. You'll have I must be equal to V over R plus, sorry, this must be negative V over R e raised to negative R L. I can factor out V over R, right? So factoring out V over R, factoring out V over R, you will be left with inside 1 minus E raised to negative R over L times the time. Okay. So this will be the formula for the simple RL circuit. Okay. So I will be your current, so you already have here the symbols that we'll be using for this formula. So as long as you know the formula, most of the problem will just be direct substitution. Okay, so with that, let's try some sample problems. Okay, so we have the first problem. A 10 ohms resistor and a 10 Henry inductor are connected in series across a source of 12 volts. So if the current is initially 0, find the current at the end of 5 milliseconds. So let's put all the givens first for number 1. So for number 1, we have, let's make it slightly bigger. There you go. For number 1, given we have 10 ohms resistor, that will be your R. Okay, so 10 ohms. And then we have 10 Henry inductor. So we have L, that is your L, 10 Henry. And then source of 12 volts, your V will be equal to 12 volts. And the current at the end of 5 milliseconds. So for the 5 milliseconds, we have T must be equal to 5 milliseconds. So typo, 5 milliseconds. Okay, so for the solution, I told you this is just a direct substitution, provided that you already know the formula. So getting back to the formula, we have um, I must be equal to V over R, right? That's 1 minus E raised to negative R over L T. So substituting all the values we have at 12, V is 12, R is equal to 10 times 1 minus E raised to R is 10, right? L is also 10. And then T is 5 milliseconds. So be careful with this one. So that in order for you to put 5 milliseconds, that is 5 milli is times 10 raised to negative 3. Okay. So all you have to do now is just input this in your calculator. You'll have here 12 times 10, 1 minus E, then negative. So this will, the answer is 5 point. So the answer is 5.9850. So I now will be equal to 5.9850 milli, that's milliamps, okay? That's times 10 raised to negative milliamps. So this will be your answer for number 1. So let's go to number 2. Going to number 2, we have number 2, of course, for the given, we have an inductance L. So we don't know the value of L. And a resistance of 10 ohms. So we have R equal to 10 ohms again. And then in series across a 100 volts source. So V must be equal to 100 volts. If the current is initially 0 and is equal to 9 amperes, so I must be equal to 9 amperes after 1 second. So T must be equal to 1 second. Find L. So now we are required to find value of L. So whatever this must be in Henry. So it's still the same. So it's still the same. Sorry about the alarm. The formula is still the same. So 1 minus, oops, e raised to negative r over L T. Okay, so let's substitute all the givens that we have. So we have I is equal to 9 equal to V is 100 over 10. That's R. 1 minus e raised to negative r is 10 over L. L is the one that we are looking for, and then T must be equal to 1. Okay, so we need to isolate now L. So using we have to do this algebraically. So let's simplify what we can. 9, 100 over 10 is just 10. That's 1 minus e raised to negative 10 over L. Okay, so this will become 10 must go down here. So 10, 9 over 10 equal to 1 minus e raised to negative 10 over L. And then e will be transposed on the other side. 9 over 10 will be also transposed to the other side. So e now will be positive 10 over L equal to 1 minus 9 over 10. So we can have here e raised to negative 10 over L. 1 minus 9 over 10, that is 1 over 10. And then take the ln of both sides. Taking the ln of both sides, e must be cancelled. Um, so you'll have your negative 10 over L equal to ln of 1 over 10. And finally, the answer is L must be equal to negative 10 over ln of 1 over 10. So this will be the answer. So let's try this out in our calcu again. That's negative 10 over ln of, that's 4.3429. 29 Henry. Okay. So that will be your answer. As you can see, this is just a simple substitution as long as you already know the formula. So I hope the derivation of the formula is really helpful. But if you find the derivation formula quite long, and I know it is long, you can just memorize the formula. But of course, derivation is much better than memorizing for me. And I think that's it for this video. And I hope I was able to help you guys, especially during these online classes. So if you haven't already, don't forget to subscribe to my YouTube channel. So of course, also hit the bell notification so that you will be notified as soon as I upload a new one. So I want to thank you all guys for watching. And if you have any question for this lesson, feel free to leave a comment down below. And have a great day, and I'll see you on the next one. Bye bye.